Buongiorno. Good morning. Yo rigelt. That's all the Hungarian I know, so I do apologize. Again, my name is Robert Ballecer. I am a Jesuit priest, a member of the West Province of the Society of Jesus. For 40 years, I've been an engineer. For 30 plus years, I've been a Jesuit. And for 20 years, I have been a tech journalist. Most recently, I was working at a technology news network called This Week in Tech near San Francisco, where I have been following the trends of technology, both in what has been evolving and how it has changed the society in which we live. Now, most recently, I've spent the last 7 years working at the Jesuit Curia in Rome as the head of studios. I've been missioned to communicate and do special projects for the Worldwide Society of Jesus. Now, one of my specialties is what we used to call big data. It's the collection, the storage, the categorization, manipulation, and utilization of very disparate data sources. Now, that's going to be important when we start talking about modern AI. The framework for today is going to be simple. I'm going to use the same structure that we used at Vatican II, and which has been used several times over in papal encyclicals. The idea is to listen, to discern, and then to act. I'm going to be giving you a lot of information that hopefully will leave you with a better understanding of what exactly modern AI is, how it works, what we can do with it, and then the consequences of that technology. That information should help you get the most possible out of the coming workshops, but what I really want is for each of you to reach the end of the day with the ability to discern what it is you want to do with contemporary AI. Now, what you just saw was me using Microsoft's AI tool called Copilot. I asked it to create an image of Pope Leo XIV in Budapest. Copilot searched its database, found an image of Leo XIV and an image of Budapest, then composited one on top of the other. Now, it's not that simple. Actually, there's a lot more going on in the background, but I think that's a general simplification of what you just saw. It didn't just do a copy and paste of one image on top of the other, but instead it adjusted the shadow, the color, the contrast. It changed the focal length of the image in the background to make it seem more realistic. Now, it's not perfect. Obviously, if you know Budapest, this is not perfect. The walkways and the bridge and the church, the shadows don't quite match. There's a reflection in the water that shouldn't be there, but for something that was done so quickly, on the fly, and without human intervention, it's actually a technological miracle. It's easy to think of AI in the same way that we've seen it depicted in films. Machines that are sentient, that experience, that learn, that act much the same way as humans. Think of Terminator or R2-D2 from Star Wars. But what we call AI today isn't that. In fact, artificial intelligence is not really intelligent, nor is it really artificial. Instead, it's all about probabilities. Modern AI looks at probabilities, the probability of what is to come next, and it generates a response based on that probability. Now, let me give you another example, but one that is easier to follow. This is Gemini. This is Google's version of AI. It's actually what we call an LLM, a large language model. It's their version of the AI that Microsoft uses in Copilot. Now, LLMs are adept at natural language recognition, and they form the foundation of modern AIs because they allow an AI model to understand what is being asked of it, based on statistical probability. And they use that same process in reverse to generate a statistically likely answer based on the data set that it's using. Now, in this case, I'm going to ask Gemini to write 2 paragraphs about growing up in San Francisco, California. I'm going to tell it to include 1 story about Vietnamese food and at least 1 joke. Now, right now, Gemini is breaking down my request, and it's comparing each word in the sentence to all the other words in order to obtain the context. Once it has that context, it understands that I have given it 5 requirements. Write a story. Write a story about growing up. Write a story about growing up in a place called San Francisco, California. That story must include a story about Vietnamese food, and it must include 1 joke. And this is what it came up with. Growing up in the city by the bay was a vibrant tapestry woven with fog-kissed mornings, the clang of cable cars climbing steep hills, and the salty tang of the Pacific air. Weekends were often spent exploring Golden Gate Park, from the bison paddock to the Japanese tea garden, or venturing across the iconic Orange Bridge for breathtaking views. The city's diverse neighborhoods each held their own unique charm, from the colorful murals of the Mission District to the bustling energy of Chinatown. There was always something new to discover, a hidden alleyway with a quirky bookstore, or a tiny park tucked away offering a moment of quiet amidst the urban hum. One of the many joys of San Francisco was the incredible food scene, a melting pot of cultures that tantalized the taste buds. I vividly remember the first experience with Vietnamese cuisine in the Tenderloin District. The fragrant aroma of pho broth, simmered with star anise and cinnamon, wafted from the open doorway of a small restaurant. My family and I squeezed into a tiny table and ordered bowls piled high with slippery noodles, tender slices of beef, and fresh herbs. The explosion of flavors, the savory broth, the bright cilantro and mint, the spicy kick of chili was unlike anything I had ever tasted before. It was a culinary adventure that opened my eyes to the rich tapestry of San Francisco's cultural heritage. Speaking of food, why don't scientists trust atoms? Because they make up everything. This is a lie, of course. This was entirely artificially generated. But the fact that it did a fairly decent job of generating text, that wasn't bad. That wasn't obviously created by a machine, is amazing. It captured some unique characteristics about San Francisco, including the fog, the cable cars, the taste of the air next to the Pacific Ocean. It even included real landmarks that real people would remember, from Golden Gate Park to Chinatown and the Mission District. More importantly, Gemini managed to create text that is indistinguishable from text that is written by a human. This does not exist anywhere. This is not on the internet. This was not written by someone. This was created by AI. Now, you should be asking yourself, how does it do this? Understanding what we're asking of it is one thing, but how does a machine create text? Text that could have been written by a real human. I hinted at the answer to this earlier when I mentioned big data and the fact that AI is all about probability. I'll give you a complete answer, probably a way more complete answer than you want, but not now. First, I think a bit of history of the development of AI will help us to understand what we're talking about and give us a better appreciation of how advanced it has become. One of the earliest seminal contributions to AI came from a man by the name of Alan Turing in the 1930s. You may know Turing from the creator, or part of the team that created Enigma, the machine that broke the Nazi codes. He was also portrayed by Benedict Cumberbatch in a very good movie you should watch called The Imitation Game. Turing was a British mathematician who introduced the idea of a universal computing machine. It's a thinking machine. His work laid the foundation for modern AI and developed to the point that he created the Turing test in the 50s, which was a method for testing if a machine could demonstrate intelligent behavior that was indistinguishable from that of a human. Now, the test was relatively simple. There are 3 participants who only interact via writing: the questioner and 2 participants, one of whom is a machine. The challenge was simply to ask questions of both participants and determine which one was a machine. If the questioner cannot determine which one is a machine within a set time, then that machine is said to have passed the Turing test. At first, it was thought that simply having more powerful computers would naturally lead them to being able to pass the Turing test, but that was not the case. For more than 70 years, no machine, no matter how powerful or sophisticated, could pass the Turing test. Not even Deep Blue, if you remember from way back when in the 90s. That was IBM's supercomputer, their expert system, which was the first to defeat a chess grandmaster. Even that was woefully inadequate to make even a modest showing in the Turing test. Now, Deep Blue was powerful. It could evaluate 200 million positions, possible moves, every second. But the problem wasn't raw power, but rather that an expert system, their AI of the time, was what we would call rules-based. Humans would create rules, sort of a flowchart of decision-making, and with that flowchart, the expert system would come to a solution. Now, that might be good at solving complex problems, but even trying to mimic human speech, it doesn't work. It doesn't work at all. In fact, it failed pretty spectacularly. But then came the 90s and the 2000s, and with it came several breakthroughs. We found the availability of large data sets. With the internet, with the interconnection of our networks, suddenly we had access to so much more data than we thought existed. We also increased the power of our computers, which made it possible to take advantage of those data sets. We also developed machine learning and neural networks that could replicate, sort of, the way that the human brain works. And we created algorithms that could learn from the data that passed through them. Then in the 2010s, we had the breakthrough that directly led to what we call AI today. Two things: deep learning, which allowed us to train AI models, and what we call transformer architectures, which convert text into numerical representations called tokens that allow machines to manipulate that text, both to understand what it means and to reassemble it afterwards. All of this led to a large language model. And it was a large language model, ChatGPT-4 to be exact, that finally passed the Turing test. Now, at this point, you've heard me mention large language models and GPT multiple times, so let's do a quick primer on what exactly that means. A large language model needs three things: data, a lot of data, architecture, and training. Let's talk about data first. In order for a LLM to work, it needs an extraordinary amount of data. How much data? Well, if you were to write a file with 180 million words, the file would be right about 1 gigabyte. LLMs on average work with 1 petabyte or more. Now, each petabyte is 1 million gigabytes, so that means for an LLM to work, it needs about 180 million words. The more data it has, the more it can understand your question and extrapolate an answer. Now let's move on to architecture. An LLM with a lot of data is just a database. Somehow you need to be able to take that database and structure it in such a way that it can be used to understand questions and then extrapolate answers. The way we do that is by pre-training the model on a small subset of that data. This pre-training creates the architecture of the LLM, which will guide the way that it acts. This is the transformer part that you might hear about of AI. The LLM looks at a sentence. It catalogs the context of every word by analyzing its relation to every other word in the sentence, and then it awards each a score, the probability that one word will come after the next. By doing this, an LLM can build a model of a sentence and the words contained within that sentence, and by building a model, it can understand. GPT-3 which is the third version of generative pre-trained transformer, was created by OpenAI about 4 or 5 years ago. It made a lot of waves in 2021 because its answers were almost indistinguishable from human-created text. GPT-3 was pre-trained on 45 terabytes of data. That's 8,100,000 million words. Now, with that pre-training, we have our architecture, but now we have to train the model. Now, what does that mean? Let's go back to the example of GPT-3. The architecture used 175 billion machine learning parameters. Now, what is a parameter? Well, we take the entirety of the data that we have gathered, 1 petabyte in the case of ChatGPT-4, and we run it through our architecture. Again, the LLM analyzes each sentence and generates parameters that predict what comes next in each sentence it extrapolates. Now, every time it guesses wrong, this is important, when it guesses wrong and is corrected by either a human or by the incoming data, it creates a new parameter to guide the next extrapolation. This is why I say that an LLM or an AI extrapolates. It doesn't think. It generates text based on the probability of each word being the next in a sentence. In other words, LLMs are exceptionally powerful pattern recognition and pattern generation tools. This is the technology on which all modern AI is based. An LLM breaks down a query, learns context from statistical probability, then assembles a response using that same process, using its data set, its architecture, and training. So, if I ask an LLM, what color is the ocean? Sorry, we have a malfunction here. No, it's evidently it wants to show you the Pope. I think my computer has become intelligent. So if I ask a LLM, what color is the ocean? It first breaks down the query and understands that I am asking it a question about the color of a thing called the ocean. It searches its data set and it looks for statistical probability of text associated with the ocean. Now, maybe it gets it wrong. Perhaps it replies, the ocean is fish, because in its data set and architecture, fish is the token that is more associated with ocean. So I correct the LLM. I tell it the answer is blue, and it adds a parameter so that the next time it is asked about the color of the ocean, it will respond with blue. Now do this millions, billions, trillions of times, and your model becomes more intelligent, which really means it becomes better at guessing the next word. Now, you might be asking yourself, okay, that's fine. That works for text. That example we did of the story about San Francisco, that makes sense. But how does it do everything else that we see it doing? The answer is that once we start reducing things to a tokenized representation, it really doesn't matter what the thing is, as long as the data set is large enough to encompass that thing. So I can start to tailor my model, my data set, my architecture, and my training to do what my AI tool needs to do. If I want my AI tool to create a chatbot, I'm going to make sure that the data set includes common ways of representing emotions and the vernacular of the internet. If I want an AI that can control, say, stoplights to reduce traffic congestion, then I'm going to make sure that the architecture can understand traffic flow information from the cameras to which the AI is connected. If I want to create an AI that can create real-time video of a virtual character, then I'm going to make sure that the database includes billions and billions of photos and videos, all broken down into their tokenized representations, so that the AI can build appropriate and convincing images. Now, let's go back, knowing that, to our image example, the one that we created with Pope Leo, kind of in Budapest. But let's break it down so that we understand what's happening along every step of the process. This time we're going to use a different AI. This is an AI from a company called OpenAI. It's called ChatGPT-4. I'm going to ask it to create an image of Pope Francis, God rest his soul, on the International Space Station. Now, first, it needs to understand what I'm asking it to do. It's an LLM, which means it's breaking down my request and comparing each word in the sentence to all the other words in order to obtain their context. Now, once it has that context, it understands that I want the image of a person known as Pope Francis to be placed in a place known as the International Space Station. ChatGPT looks through its dataset to find suitable images or tokens that represent what I'm asking it for. Now, it has to modify them. It has to generate them to fit my request. So it takes the foreground image of Pope Francis and it places it on the background image of the International Space Station. And it has to make sure to match perspectives of the foreground and the background. Next, it's going to match shadows and color temperature of the two images. For it to know how to do that, it has to be able to identify individual elements within the frames of both images so that it can process which elements will throw shadows and how much of a shadow. It's identifying light sources, and then it's using their relative position within the frame to understand how those elements should look together. And finally, it will composite a final image. Now, it should be noted that it's difficult for a human to do this. We've been modifying images for decades upon decades, and even for us, it's an art. It's not a science. And so the fact that ChatGPT, an LLM, can do this is actually pretty astounding. This is the technology on which the AI revolution is based. Now, hopefully you understand what I mean that it's all probability-based. I repeated the query multiple times while adding additional requirements. Show Pope Francis standing at a slight angle. Show Pope Francis waving and smiling. Show the earth behind Pope Francis. And each time, ChatGPT created an image that fit the statistical likelihood that it would fulfill my requirements. Again, it's all pattern recognition. Obviously, this photo never existed. And what LLMs can do with those patterns is quite amazing. It's actually much more than just stories about growing up or fictional photos of Pope Francis in space. Researchers at Harvard Medical School built an LLM AI system that trained on 15 million scans and 60,000 slides of the images of internal organs. The researchers discovered that the model wasn't just good at finding patterns of cancerous cells, but also that it could be trained to evaluate both specific sections of a patient's body and the entire body in context, something that a human doctor cannot. By giving it the capability to do both micro and macro inspection at the same time, the model achieved a 94% accuracy rate in cancer detection for 11 types of cancers. 94%, that's above and beyond anything a human could do. Now they're continuing to train their model, which should give it an even higher accuracy rate and the ability to recognize other types of cancer. LLMs are also used in the fight against human trafficking. Veritone, which is a supplier of enterprise-level AI solutions, has been working with law enforcement to build AI models that can identify potential human trafficking activity. Their model takes large, disparate databases. Remember, that's the thing about AI, it takes a lot of data. And it uses its model to break down what it means. By taking those databases from ISPs, Internet Service Public and Private Data Logs, and the like to uncover hidden patterns of communication, of transportation, and logistics involved in human trafficking, it can identify where human trafficking likely exists. Now, once the model has identified its likely networks, it can be turned on individuals within those networks, and law enforcement can get involved. We can even use LLMs to make machines program other machines. Now, I'm going to ask ChatGPT-4 to write code for an Arduino. I want it to control a string of WS2812 LEDs and give them a rainbow color. Very simple. This is something that a beginning programmer might do. Now, ChatGPT has in its data set multiple code repositories. That's the data that has been given to it. And it has a trove of information about the Arduino. So it can easily create basic code that drives WS2812 LEDs while also giving me basic instructions on how to complete the circuit. And this is what it has come up with. Now the amazing thing is I can take this code, or actually I did take this code, and I've loaded it onto this set of cyberpunk goggles that I made years and years ago. And if ChatGPT did its job, I should be able to just plug this in, and it should give me the control of WS2812 LEDs with a rainbow color. This is a machine programming another machine. And it actually does it quite well. I did make a couple of changes to make them look a little bit better, but it worked out of the box. Even if I had no programming experience, even if I had never touched these goggles, even if I didn't know what an Arduino was, I could write this into ChatGPT, it would give me the instructions on how to create the circuit, and it would give me the programming to drive it. That actually is nothing short of amazing. You should have a good idea of what LLMs are good at. In one of my workshops today, I'm going to demonstrate a few examples of how AI can be used in education, both in the creation of educational content and how to integrate it into lessons so that it becomes a tool of critical thinking rather than a temptation for students to take academic shortcuts. What you saw right now was me using it to create a logo for a fictional event in Japan for World Youth Day 2050. I only told it that I wanted to use the colors of Japan and the Vatican and to use some religious iconography. And this is what it came up with. Again, this does not exist. This is not a real event. These graphics have never existed anywhere on the internet. And yet it understands well enough about religious events, Japan, Vatican, World Youth Day, that it was able to composite this in just a few seconds. But I promised at the start of this talk that we would follow the Vatican II framework of listen, discern, and act. And for us to properly discern, we can't just look at how AI works and what it's good at. We need to consider the downsides of the technology. Now, one of the most obvious downsides to the technology is that it is not friendly to our common home. OpenAI's ChatGPT receives 10 million queries a day. On average, each AI query uses about 4 watt-hours of power. That doesn't sound like a lot, but then you have to multiply that by the number of queries that not only OpenAI and ChatGPT gets, but all the AIs in the world, and some of them are extremely inefficient. There are about 70,000 AI companies worldwide. The US has about 17,500. 82% of all companies, that's 266 million, are starting to or considering the use of AI in their products. There are at least 10 billion search queries per day. Many of those are transitioning to AI. If all of those searches go through LLMs instead of the standard search, that's 40 gigawatts of power just to handle the query. A typical nuclear plant generates on average 1 gigawatt. That's almost 2 nuclear power plants dedicated entirely to nothing but answering AI queries. And that's assuming that we stay at the levels that we are at today. Clearly, that's not sustainable. Google, Amazon, and Microsoft have all expressed interest in building their own nuclear power facilities just to keep their AIs online. Imagine that, building a multi-billion-dollar power plant just so you can handle me asking AI to write a story about San Francisco. And it's not just power and carbon dioxide. A study from the University of California found that AI data centers are exceptionally water hungry. As the silicon used for AI data centers tends to run hotter and is packed more densely, a single ChatGPT-4 query uses up almost 1 liter of water. Now multiply that by the number of queries and you are basically running an ocean through your data centers, fresh water that you're getting rid of just to keep the machines from melting. Now, another potential downside is the unchecked usage of AI in law enforcement. There have now been in the United States a dozen cases that we know of in which people have been falsely detained because an AI tool was improperly used by law enforcement, and it identified the wrong person. And that person was arrested and held purely on the testimony of an AI. While LLMs are good at pattern recognition, you have to remember its answers are still extrapolations based on probability. They are not facts. Another drawback to AI is the tendency to what we call hallucinate, and its proficiency at creating misinformation. When an AI hallucinates, it fabricates facts, it misinterprets existing data, or it creates entirely fictional references based on what it thinks a reference should look like. Well, since AI systems predict the most likely sequence of words based on training, they can sometimes generate plausible sounding but factually incorrect content. Closely related to that is the proficiency in which AI can create disinformation. This has the same effects as a hallucination, but while a hallucination is a glitch, disinformation is done on purpose. Because LLMs can create content much faster than humans, and because the most advanced models have finally passed the Turing test, it's possible for a very small group of people to flood the internet with false but seemingly true information. Doing so not only spreads disinformation, but it decreases trust in information that is factual and truthful. The last drawback that I want to bring to your attention is one in which Catholics should be particularly mindful. Pope Francis and now Pope Leo XIV have sounded the warning about the potential for AI to dehumanize, alienate, and isolate. Recently, Mark Zuckerberg addressed the loneliness crisis brought about by information technology, taking the place of real interpersonal relationships. His answer was for people to create AI friends with which they could build a relationship. That devaluation of a real relationship is the same threat that the world faced during the 1800s, during the Industrial Revolution. Well, thankfully, this ends us on a high note, because the Catholic Church has dealt with this before. In the late 1800s, the encyclical Rerum Novarum specifically addressed the dehumanization, alienation, and isolation brought about by the Industrial Revolution. Issued by Pope Leo XIII, it became the blueprint for Catholic social teaching, an absolutely vital component in the fight against dehumanization. I'd posit that the same lessons from then are compatible with fighting the AI revolution now, the worst of the AI revolution. This should be a major component of our discernment, that the Catholic Church and her ministries are uniquely positioned to provide a path through the AI revolution that at once can take advantage of the promise of AI while not losing ourselves in the process. I ask for you to take that into your day. Listen, discern, and act. Thank you.